So determine the DC bias voltage VCE and current IC for the voltage divider configuration using exact analysis. Okay, so your diagram is given with the voltage divider biasing and you have to do it using exact analysis. So before going on to the problem, let me just recall about the exact analysis. So in the case of exact analysis, what did you do? The input side was converted into Thevenin's equivalent circuit, right? Thevenin's equivalent circuit. So how did you redraw your input side? So if I can draw the input side of your circuit, so this is going to be your VCC and R1 and R2, which will be grounded, and this will be going to your base, right? Across the resistor emitter, you will be having your resistance Re. So since it is DC equivalent circuit, you will be having all your capacitors to be open circuited, right? And now you will be applying Thevenin's theorem across this input side. So what is meant by Thevenin's equivalent circuit? It simplifies a complex circuit into a single voltage source and a resistor in a series. So what will be your Thevenin's equivalence resistance? I can tell that RTH will be equal to R1 parallel to R2, and what will be your ETH, that is your Thevenin's voltage source. So ETH will be equal to, so ETH is equal to VR2, right? The voltage across the resistor R2, which will be equal to, you can apply the voltage division rule. So source voltage, that is VCC into R2 divided by R1 plus R2. So this will be your equation 1, this will be your equation 2. So now you have got the value for RTH and ETH, so you can reconfigure the circuit into the Thevenin's equivalent circuit, as you can replace it by ETH and you will be getting RTH in series, right? And you will be having this base, and across the emitter you will be having your emitter resistance Re. So the voltage here, it will be VBE. Here the voltage will be maybe the current is equal to IE. So VE will be equal to IE into Re. So if I apply the loop equation across this, so what will be your loop equation? So it's a minus to plus, so it will be plus ETH KVL if I apply across the input loop. So you will be getting ETH, then here plus to minus, right? So plus to minus, let me assume the current here as IB. So minus IB into RTH, then here it is plus to minus. So minus VBE, again plus to minus. So minus IE into RE is equal to 0. So as we have seen in the previous case, so what is your relationship between IE and IB? You know that IE is equal to beta plus 1 into IB, right? So when you substitute this in the above equation, so you will be getting ETH minus IB into RTH minus VBE. Instead of IE, I am going to substitute it as beta plus 1 into IB into RE is equal to 0. Can I take IB as common now? So what you will be getting ETH minus IB, if I take it as common, here you will be getting RTH. So minus, so here you will be getting plus beta plus 1 into RE as common, right? Minus VBE is equal to 0. So what you have to find out? Ultimately, you have to find out your IB. So if I take IB to the opposite side, so you will be getting ETH minus VBE, which is equal to IB into RTH plus beta plus 1 into RE. Right? So what will be your IB? IB will be equal to ETH minus VBE divided by RTH plus beta plus 1 into RE. So this will be your IB. So if you know your IB, you can calculate your IC. What will be your IC? IC is equal to beta into IB. So you can calculate IC by using this formula. Now what will be your VCE? So VCE, Across the output you have to apply KVL. So what you will be getting, there is no change, it is similar to that of the previous biasing. So you will be getting plus VCC, right, plus VCC, here it is plus to minus, so minus ICRC, here it is plus to minus, so minus BCE, here it is plus to minus, so this will be open circuited, right? So now plus to minus, so minus IE into RE is equal to 0. You know that what is the relationship between IE and IC? IC is approximately equal to IE. So you will be getting VCC minus ICRC minus VCE minus IC into RE is equal to 0. Take IC as common, VCC minus IC into RC plus RE minus VCE is equal to 0. Solving, we will get VCE is equal to VCC minus IC into RC plus RE, right? So these are the two different equations. Now you can find out the value for IC as well as VCE. Now we can again solve the problem. Okay, so first let's move on to the first part, that is your aim is to find out your IC. So IC is calculated by using beta into IB, right? So now you have to calculate first your IB. So for that you have to find out what is your RTH. RTH is equal to R1 parallel to R2. So what is your R1? R1 is equal to 39 kilo ohm. 39 kilo ohm parallel to R2 is equal to 3.9 kilo ohm, right? Now what will be your formula? So 39 kilo ohm into 3.9 kilo ohm divided by 39 kilo ohm plus 3.9 kilo ohm. Okay, so when you solve it, so what is 3.39 kilo ohm into 3.9 kilo ohm? So somewhere nearer to you will be getting 152.1 into 10 raised to 6 divided by 39 kilo ohm plus 3.9, you will be getting 42.9 into 10 raised to 3, right? So after solving, you will be getting RTH is equal to 3.545 kilo. So RTH, you have got the value. Now the next value which you have to find out is ETH. ETH is equal to, what is the formula? VCC into R2 divided by R1 plus R2. So what you will be getting? So ETH is equal to, what is your VCC? VCC is equal to 22 volt. 22 volt into, what is your R2? R2 is equal to 3.9 kilo ohm divided by R1 plus R2. That is R1 is equal to 39 kilo ohm plus 3.9 kilo ohm. So after solving, you will be getting 22 volt into 3.9 kilo ohm, you will be getting 85.8 into 10 raised to 3 divided by 42.9 into 10 raised to 3. So you will be getting, after solving, you will be getting it as 2 volt. ETH will be equal to 2 volt. Okay, you have found what is ETH, RTH. Now can we find out what is your IB? IB is equal to ETH minus VB divided by RTH plus beta plus 1 into RE, right? RE. Okay, so what is your ETH? ETH is equal to 2 volt minus, you know that VB is equal to 0.7 divided by RTH, you have calculated as 3.545 kilo ohm plus beta. What is beta given? 100. So 100 plus 1, it will be 101 into, what is your RE? RE is equal to 1.5 kilo ohm, right? 1.5 kilo. So you will be getting somewhere nearer to 1.3 volt divided by 3.545 kilo ohm plus 151.5 kilo ohm, right? So you, after calculation, you will be getting IB is equal to 8.38 microampere. Okay, the unit, you should be very careful with the units. So you are getting IB is equal to 8.38 microampere. So what will be your IC? IC is equal to beta into IB. So 100 into 8.38 microampere. So you will be getting IC will be equal to 0.838 milliampere. Okay, you have got the first DC value, that is IC is equal to 0.838 milliampere. Now you have to calculate what is your VCE. VC is equal to VCC minus IC into RC plus RE, right? So what is your VCC? 22 volt minus IC is equal to, already you have calculated. So 0.838 milliampere into, what is your RC? RC is equal to 10 kilo ohm, right? 10 kilo ohm plus RE is equal to, what is the value for RE? 1.5 kilo ohm, which is equal to 22 volt minus, you will be getting somewhere nearer to 9.66 volt. So VCE is equal to 12.34 volt. So you have got the value for IC and VCE. IC is equal to 0.838 milliampere and VCE is equal to 12.34 volt.